Okay, hello again. So in the last video, we started talking about client-side scripting, a little bit of the history, and we're now getting into the area where jQuery is taking over. So just to give you a little bit of a perspective here, we've been talking about web pages rendering and elements on the page so far, right? So we have our various tags with attributes and things like that. These all fall in line with our DOM or our document object model. Now, this is basically the easiest way to think about it is it's a tree-like representation of all of your elements on the page. So, for instance, we have a document object. The first element in this thing is going to be our HTML tag. Then we have our head tag. Inside of our head tag, part of the tree, we're going to have various aspects, so title, script, style, all these pieces of the head block. And then we'll have another block called body. Inside body, we'll have our header tags, our article tags, nav, footer, paragraph, everything that we've defined so far. Now, this is commonly referred to as the DOM, the document object model. And basically, it's a very nice and easy way to access every single element on our web page. And why are we talking about this here rather than way back when we did a bit of HTML? Well, the entirety of client-side scripting is based around the idea that we can very easily manipulate the DOM. We have very nice, clear, easy ways to handle events triggered by DOM elements. We have easy ways to update styles and classes and text, positioning. Everything that you see rendered on the page is completely malleable by our various DOM attributes and functions. And it's standardized, which is nice, which also means that every browser can hopefully choose to implement our DOM properly. So I've got a convention here for accessing elements, HTML, XHTML, XML. We're mainly focusing on the HTML aspect, but you can technically manipulate a XML tree as well. And again, XML is just a data storage technique, so I could have, document Dr. Frederick's amazing data package, results one, attribute one, value one, so on and so forth, however you want to define it. But the key here is it's a tree, which is pretty easy to parse out from a computer science perspective. So why did I start with that? Well, we're going to be using JavaScript to manipulate this, and all of the attributes that we have are accessible by JavaScript. And if you're not a JavaScript developer, a little bit of history here. So for some reason, this is still persisting. JavaScript is not Java. It has nothing to do with Java. Its syntax is different. A lot of the paradigms are different. Historically, Java and JavaScript were linked purely for marketing purposes. So JavaScript came out and needed popularity. Let's call it JavaScript. People know Java. Well, JavaScript, people will hopefully understand that. Basically, pure marketing ploy, and it's confusing the heck out of people to this day if you're new to coding, which is fine. The other interesting thing is that around the time that JavaScript starts becoming popular, there are lots of coffee-like derivatives. So there's JavaScript, there's CoffeeScript, there's a couple of other ones too that I don't remember offhand. JavaScript is basically kind of won out over pretty much everybody else, but you still see, people using the other scripting languages as well. Technically, very technically, it's called ECMAScript, and this is effectively a standard for these client-side scripting languages. JavaScript is one implementation of that. If you go to the wiki page for ECMAScript, you actually see a tree of all the different scripting languages that implement the ECMA standard. It's technically just commonly known as JavaScript, though. There's a lovely quote. ECMAScript is always an unwanted trade name that sounds like a skin disease. So JavaScript's a little bit better. But as a bit of a timeline here, so I grabbed this off of a Medium article. JavaScript is born in 95. ECMA standards are established. Standards kind of update and change. AJAX becomes popular. Object-oriented programming becomes popular and comes out. ECMAScript gets more features, syntactic sugar added, which basically means that or adding features that are debatable if they're useful, but they maybe make people's lives easier, or it depends how you want to look at it. Basically, the idea is this has been around for a long time, and it's really now just becoming popular. And just out of pure personal history with JavaScript, this point in time, honestly, so this area I'm highlighting, JavaScript is pretty terrible. Um, as a web developer who did stuff in this era, browsers did not implement JavaScript the same. You would have to have code in your web pages that would check, is JavaScript supported by your browser? Is it implementing things correctly? Because if I write JavaScript commands, it's going to do something different in Internet Explorer than it would do in Netscape Navigator or Firefox or Chrome or Safari or Opera. Um, Now things are a little bit more standard, which is great. But the fact that it was so rough to use during this time frame means that, to me, the idea of Node.js is kind of interesting because now JavaScript's a major backend language, and it's a personal issue. Anyway, don't let my biases inform you here. So JavaScript, it is very easy to learn. The syntax is very familiar if you know C or Java or C# or any of the kind of common core languages. So if you see a JavaScript application, you're going to be fairly comfortable with it. Obviously, syntax will be slightly different. Um, some behaviors might be different, but you're not going to look at this and say, I've never seen this before, right? It's not like looking at Lisp or Clojure or any of these other kind of interesting languages. So what do we have? So we have common, comfortable terms. We do have the idea of closures in here. Functions are basically first-class citizens. We do a lot of inheritance from object prototypes here as well. We're not going to dig too deep into that, but basically, JavaScript is a very malleable language. And as you start playing with it, you'll see this weak typing thing here is really, really interesting. As a side note, if you don't like this, there are more rigorously defined languages like TypeScript, where data types are enforced, and basically it's a lot more rigorous in its design. JavaScript, you could define a class object, and then halfway down your program, you can redefine it, or you can add attributes that never existed before. And you can change it from a float to an int if you want, and it doesn't care. So basically, it's easy to fall into some kind of pitfalls with JavaScript if you're not super comfortable with coding. My suggestion would be try to avoid being lazy with it because it will come back to bite you at some point. So a bit of a historical perspective, I kind of mentioned this already. JavaScript used to basically just be for interaction, so we can make really annoying buttons like this, where we change the XY position of the button once the user hovers over it. Used to be used for pop-ups a lot, updating styles, unhiding or hiding content, simple things. Ajax comes along, the idea of clients and servers talking and sharing data. JavaScript becomes a little bit more popular. Recently, it is a full stack implementation. You use JavaScript for Node.js on the back end, or React. It's basically the entire thing, which is really, again, kind of amazing to think of from a historical perspective. Okay, so a bit of an odd cut. I recorded the first half of the video yesterday and had to leave early. So second part of this video is now me in a completely different outfit, even though it's days later. Anyway, what we're going to be going over now are some examples of JavaScript. And again, these JS fiddles come from Dr. Engelsma. Rather than modify them, I figure I'll let them shine because they're perfectly good and valid and are saved up on the internet for posterity, which is great, so that you can play with them as well. Now, these are basically going to highlight some of JavaScript syntax. This is not, again, going to be like a full deep dive into every little piece of how JavaScript works, but more so that you can start getting a feel for how things fit together, how to call functions, how to declare variables, things like that nature. If you already know everything about JavaScript, feel free to skip this, but honestly, it's kind of a good refresher. And again, this is going to be pure JavaScript. This is not TypeScript. At this point, we're not bringing any libraries in. Soon we'll bring in jQuery, raw JavaScript. So this first one is just basically going to go over some of the syntax for JavaScript. Now, again, down here is our JavaScript code. Here's our canvas. And we've got some, can I scroll this up a bit? Oh, good. JS Fiddle's really fiddly with these little borders here. So with JavaScript, we have no concept of variable type, really. Well, we do. I guess let me step back, but we're going to declare them as a generic var. So here you see var x equals 10, var y equals 10, but in quotes. Basically, this is implicitly defining it to be an integer or a string. JavaScript's not going to care one way or the other until you force it to care. And let me give you a little example here. So this is a really nice visual of how type checking can work in JavaScript and how it could easily trip you up as well. This first one, so here we have two if statements. If x equals equals y, do something. If x equals 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 y, do something. So let's go ahead and I'm going to comment out this later on code. We'll talk about that in a moment. But I want to show you this here. So let's go alert x equals y. And then also down here, we'll do the same thing, except we'll call it triple equals. Now, these both mean basically the same thing. It's a comparison operator. One sec, excuse me, I had to sneeze. So basically these are comparison operators. This first one is just checking the value inside. Is this thing the same as this? JavaScript's just going to look at the inner type and see, do they match? Here, by adding on this extra equal, it's also going to check the type of the variable. So we should see an integer does not equal a string, right? So when I run this, x equals equals y, life is good. We don't see the second one, right? Because these types are different. If I were to change this to just be 10, I run it again, they both come up, right? If I were to change this to 10.0, so this is an int that's a float, see the first one, you see the second one, JavaScript's converting it down to an int basically, or it's converting the x to a float. I'm not exactly sure which way it's going to go, but it's a number of some kind, and that's what it's comparing there. Basically, if you want to enforce an exact match, you would do this. And why do we care? Why would we do this? Again, JavaScript is very weakly typed. You can put whatever you want inside of a variable, right? This y could be a int, it could be a float, it could be an object, it could be a class, it could be a color, it could be anything. Its potential is limitless. But you sometimes want to check the type as well. Is it necessary? Depends on the situation, right? So let's go ahead and undo all of our changes here, and let's go to the bottom. So hopefully this makes sense. I guess one other thing too, instead of var, we could say let. That's a more common one that I've been seeing lately. Let x equals 10, let y equals 10. Functionally, I think they're pretty similar. If I wanted this to never change, we could say it's a const, and then, try not to change it ever again after that because it should never change. But defining variables, we're not really giving it a type. If we gave it an int, it's not going to know what that is because this doesn't exist here. So we've got our variables, we've got our if statements. Now we have arrays, we have loops, we have functions. So here I've got var a equals 1, 2, 3 for var I in a, alert a bracket I. Basically what we're doing here, this is one way to do a for loop in JavaScript. If you look up for or for each, there's several different syntaxes that you could use. This is basically just iterating through. So if I run this now, I'm going to see 1, 2, 3, which matches that. So let's change this to something a little more A, B, C. Right, 1, 2, A, B, C. Right. So it's just iterating based on each object in this array. I could just let's do this a different way. For let I equals 0, I is less than a.length, I plus plus. We'll get the exact same thing. A, B, C. Difference here is that This is kind of your more standard like C++ Java approach where you loop over the length of an array rather than have a for each style loop. Again, there's multiple ways you can write these. So pick one that you're comfortable with and go forth and use that. All right, last bit. So we've got functions as well. And this one, you see it's declared with function for the keyword, the name of your function, and then parameters go in, again, type less because we don't have types. So I could say, let's call this name Eric, put my last name, because why not? Change this code to be alert. Oh, we could be cute about this. Let's use the injection syntax. So backtick, $, brace, param1, $brace, param2. And now what we should see is, so let's comment out our loop here. Run. Hey, look at that, Eric Fredericks. Basically what I'm doing here is I'm just injecting this variable into a string. I could just as easily have turned this into alert param1 plus a space plus param2. It's going to work the exact same. And I've got a typo. Yes, right here. So exact same thing, basically. This secondary syntax that I just used kind of reminds me of like the dot format call in Python. So I like it. You don't have to, pick it up if you don't want to. So basic syntax here, again, looks like a pretty standard Java or C++ program or something like that, but the syntax is slightly different.